Okay, today we'll be dissecting the source code of a doubly linked list. So the source code is quite similar to that of the simple linked list. But let's take a look first at the structure of the node. So this is the node that we're going to create. So in this example, we have data and key, and we have here now two pointer nodes. Two pointer with the node format, so the same format. So these are next and previous. So in a single linked list we only have next, but for a double linked list we have next and previous. And we also have here three more pointer variables. We have head, which will be pointing to the first link. We have last, which will be pointing to the last link, and current, which will be pointing to the current node. So let's first take a look at these simple functions. We have isEmpty. So again, so similar to a single linked list, if the head is pointing to null, then that is an indication that our list is empty. And again, the same for length. We just traverse from head up to the last node. So that means current now is equal to null when we reach the last node. So we always go to the next current node, and current will start from head. So again, from the head to the last node, we just add one to length. So this will count the number of nodes in our list, and that count will be returned by this function. More or less, these are the variables we have. So we have head, we have link, we have last, and then maybe later on we have previous and current. And this is the structure of our link. We have previous, next, and we have the key and the data. So assuming these are memory addresses. So in the insert first, the first code here, or the first line of code, will actually again allocate a memory with the size of our node. So the size of the node will be allocated, but again, that is just it will just allocate memory, and that memory should be typecasted to the node structure. So struct node and then the memory allocation, and that will be our link. So our link is pointing to that particular address. So we allocated a space for this link, assuming that is placed here. So we allocated this memory, and that memory is typecasted to a link pointer. So link now is pointing to this. So we could say that link is pointing to 110. That's the address of the link. And then next, so we have here two parameters, key and data. So I haven't placed values yet. So assuming that key and data, key is, let's say for example 1, and data is 10, for example. So our code will just assign key to the link key and data to the link data, and for link previous will be assigned null. So our key is 1 and link is pointing to this address. So link key will be assigned 1 and data will be assigned 10, and previous will be assigned null. Then we first test if our link is empty. If the link is empty, then last is equal to link. So at first our list is empty. So if the list is empty, then last equals link. So also here since this is the first node, then our list is So last will also be pointing to link, so this will be equal to 110. So if not, head previous is equal to link, so we will not be passing through that yet. So link next is equal to head. So link next, so this is the link next is equal to head, but head is actually null, so this one is also equal to null. And then the code says head is equal to, so head is equal to link, so this is also address 110. So we could see here that this is our first node and it is also our last node. That's why both head and last are pointing to this node. So let's say we want to insert another node. So let's say we have key and data are 2 and 20. So again, in our code, it will first assign or allocate memory, and then we typecast that to a link. So this will now be our link. So our link will be address 120. So that's our new link, basing from our code. So we have created our link. So link now is pointing to 120. And then we assign the following: the key, data, and null to previous. So our key is 2, data is 20, previous now is null. Is empty? No, it's not empty. So head previous is equal to link. Head is pointing to 110. And head previous is this one, so this one should now be pointing to link. And what is the address of link? Link is 120, so this one becomes 120. And then, so again, it is not empty, so it will pass through this. The next link next is equal to head. It's equal to head. So link next, this should be equal to head, which is actually 110. And head is equal to, so head is equal to link, which is actually 120. So if you're going to look at our list, head is pointing to this, while this node is pointing to the next, is pointing to this one, and this one is pointing to null, which is the end of our list. Okay, so that's our list. So let's try to add another one. So again, it will allocate, let's say again, our data is key is 3 and 30. So again, the first part of the program is it will allocate memory. Let's say that is placed at address 130. So link is now at address 130. Then what is next in our code? Is it empty? No, it's not empty. So head previous is equal. So head is pointing at 120. So this is that address. So head previous is this part is now equal to link. So this becomes 130. And then what's next? Link next is equal to head. So link, this is the link next is equal to head, which is 120. So this is now pointing to address 120. Okay, I forgot, this is 330. So again, this is now pointing to 120. And in the case here that head is equal to, so head is equal now to link, which is 130. So our head is pointing to this, and the next pointer of this one, the first node, is pointing to 120, and the next node of this is pointing to 110, and this one is pointing to null. This is the end of our list. Again, last is now pointing to this, head is pointing to this. So that is our list. The insertlast function. So the same will be providing with the key and data. So let's do that first. So let's say the key now is 4 and data is 40. And then we create a link and then assign the key and data to the link. So let's say, for example, we created the link, and let's say that link is now on address 100. Then on the next code, we assign the key and data. So key and data should be 4 and this one becomes 40. And the link address now is 100. So the link address is 100. So let's go back to the code. If is empty, so it is not empty. So we go to this part. Last next is equal to link. So previously, this is our last. So last is pointing at 110. This is our last. So last next, go back to the code. Last next is equal to link. So this is last next should be now equal to 100. Okay. And so that means that this one now is pointing to this. Oh, sorry. Let's erase that one. That means that this one is now pointing to this node, or the link, the new node. And then link previous is equal to, so this is the link previous is equal to last. So this one now becomes 110 because that is our last. So becomes 110. And then last is equal to link. So it goes out of the if statement and then link. So last now is equal to 100. Okay, so we have now inserted this. So if we check our list, so head is one. Our head is pointing to this node, and then the next node of the head, or the first node, is pointing to 120, and this node is pointing to 110, and this node is pointing to 100, and this one is pointing to null, which signifies the end of the list. Okay, so for the previous values, so the last link, so this is our last link. So you notice that's 100, that's our last link. So our last link, the previous is pointing to 110, and this one, the previous is pointing to 120, this one is pointing to 130, and the previous is pointing to null. So that is the link in reverse. So now let's discuss the deleteFirst function. So we have here the code. So in our code, first we created a link named temp link equals head, and actually this is the link that will be deleted because this function returns the deleted node or deleted link. So since we're going to delete first, temp link is equal to head. So this is the temp link, and this is what is going to be deleted. So if head next is null, so head next is null, that means there's only one node. So if there's only one node, then last equals null, because everything will be deleted now. So last is now pointing to null if there's only one node. But if there are more than one node or more than one link, then we have here head. So head next. So head is pointing here, and next is pointing here. Previous is 1. So instead of 130, that should now be equal to null. Okay, so head, next, previous, so this is that part, is equal to null. So we replace this 1 to null. And then head. So again, head next. Head is equal to head next. So head next is actually 120. So we replace this one now with 120. So that is this part of the code. This is part of the code. Head is equal to head next. Then, so that's it. So if you're going to look at our list, head now is pointing to this part, and next is pointing to 110. This one is pointing to 100, and then that ends the list. So nobody's anymore pointing to this. Even the previous year is now pointing to null. So that means there's no link that is in this that is previous to this particular node. So here we have already deleted the first node of our link. Okay, so now let's discuss the deletelast function. So let's simulate the code one by one. So the first part will be this one. So what will this do is just to store temp link, which is now equal to the last node or the address of the last node. So this will be our temp link. Actually, that's the node that will be deleted. So why are we doing this? Because if you can see on the last code, this function returns the node that was deleted. So we just store that in temp link so that later on we'll be returning that particular link. Then here we're just going to test if there's only one link. So if head next is null, then that means that there's only one node. So if there's only one node, we just assign the first node of the head equal to null. So however, in our case now, there are more than one node. So it says here that last. So what is our last? Last is address 100. So this is our last. Last prev. So prev is pointing to 110. And then next. So this is last. Prev next. So this one should be now equal to null. So we'll be replacing this to null. So why are we doing that? Because if we're going to delete this node, then that means this becomes our last node. And if this becomes our last node, it should now be pointing now to null. And then last, so let me remove that first. Last previous, so this is our last node. So last is equal to last previous. So this is our last previous. So we're going to replace last now equal to 110. So that means our new last node now should be this node. So this is our new last node. And that's it. So since this is now our last node, this one will now be ignored by the list. So it's now deleted in our list. The delete function. This delete function now will first search for the node with this given key, and then after that, then that particular node will be deleted from the list. So the first part, this part is actually more on a search function. It will search for the node with this key. Actually, it's making use of linear search algorithm. But in contrast with the previous, with the single linked list, here we have to know the previous and the current nodes. So we have to know the previous and the current nodes, because the previous node for delete will point to the next node of the current. Okay, so anyway, we'll be discussing that. So at first, you can see here that we have two pointers, current and previous. Current is pointing to the head, so head is pointing to 130. So actually, we could say that this one is our current node, and previously, or previous, actually the previous pointer is pointing to null. So if head is null, so that is just to test if the list is empty. So here on this part, we'll be searching. So this part will be searching until our current key. So current key is equal to the key argument. So we're comparing this with this. So they are not yet equal. So if they're not yet equal, we just proceed to the next node. So it says here that previous is equal to current. So previous here now will be equal to 130, and current, so this is the current, is equal to current next. So it is 120. So this becomes our current node, and this one is our previous node now. So let us go. Okay, so the yellow one is our current node, and the pink one is our previous node. So let's again test if the key is equal, in current key is equal to the key, the argument key. Again, they are not equal. So what we're going to do, move to the next node. So this becomes our current node. Becomes our current node. This becomes our previous node. That's it. So this is now our current node, and this is our previous node. Then once you go back, current key, is it equal to the key? Yes. So if it is yes, it goes out, because again, this will loop while the current key is not equal to the key. So it goes out of the loop. So again, the pink one is our previous node, and the yellow one is our current node. So if current is equal to head, of course not. So if current is equal to head, as if we are deleting, we're using the delete first. So since we are deleting actually not the first element, so we go to the next one. So current previous next is equal to current next. So this one is current previous is pointing at 120. Okay, so current, this is current previous next. So previous is 120, next is this part. So this is current previous next. So should be equal to the current next. So this is current next. This is current previous next. So this one should now be equal to 100. So it should be pointing to where the current node is pointing also. So this one now is pointing to this part. And then the next one, if current is equal to last, so it's not current equal to last. Now if this is true, then at least we're at as if we're doing the delete last. So we're not doing the delete last here. So current next previous. So this is current next previous. So this one should be pointing to, should be equal to current previous. So current previous is 120. So this one now becomes 120. So if you're going to look at our list now, so then it will just return the current node. So we're going to look at our list. The head is pointing to this, so this will be our first node. Then this one is pointing to 120, so that this should be our next node. And this one is pointing to 100, so this should be our next node. You notice this node was actually skipped because it is no longer part of the list. So it will go to this node, and then next is null. Okay, so how about if we go backwards? So from the last, previous is 120, so this is 120, so this is our previous. Again, it will not pass through this node. Then previous is 130, then previous is null. That means that's the beginning of the list. So again, using this algorithm, we were able to delete this node, the target node. Okay, so let's now discuss insertafter. So for this one, we need 3 arguments. First, the key. So let's say again, our key is 1, for example. And then the new key. Oh, I don't have a new key. So new key. Let's say, for example, my new key is 5. And data, let's say it's 50. So what this function will do is, first, in this part of the code, we will be searching for the key. So it's actually again a linear search. So it will start with the current. So the current is pointing to the head. So this is our current node at first. So this is our current node. And then we compare the key, the current key, if it is equal to the argument key. So they are not equal. So while they are not equal, we keep on looping. So until the time that we reach the last one, or this becomes false. So if not, then the new current, so this is the current, is equal to current next. So instead of the current as 130, so again, initially current is 130, the new current now becomes equal to current next. So this is current, this is current next. So this becomes 120, and then that means that this is now our new current. Okay, and then again, they are not yet equal. The key is not yet equal to the key argument. So if they're not equal, move to the next node. So in the next node, we replace again the value of current. So current here becomes equal to current next. So this becomes 110. And that means now that this is now our current node. Then we go back to our loop. We compare if key is not equal to this key. They're equal, so this becomes false. And if this becomes false, we go out of the loop. So that means that this is now our current node. So again, this is our current node. So current is now pointing to address 110. Then let's proceed to the next part of the code. So what will this do is, first it will create a new link, just like what we have done with our other insert functions. So assuming that it will create a new node, assuming that it is on address 90. So it creates a new node, and then the new key is equal to the key. So our new key is 5, so this becomes 5. Then data, will be placed on the new link. So again, this is the link. So this becomes 50. Our link is on 90. And then if current is equal to last, that means we're inserting last. So this will resemble that insert last method. But since we're not inserting at the last, it will do this. So new link. So this is our new link. Our new link previous is equal to current. What is our current? This is our current. So let me shade our current. So that's our current. That's our current node. So it says here that new link next. So new link next. So we're here, right? So new link next is equal to current next. So this is our current next. So the new link next, so this becomes 100. Okay, so new link next is equal to current next. And current next previous, so this is our current next. So current next, that is pointing to this, previous is equal to new link. So this becomes 90. Okay, this is current next is pointing to 100, and previous, so this is now pointing to this, referring to this data, becomes equal to the address of the new link, which is actually 90. And then new link previous, so new link previous is equal to current. So what's our current? It's 110. So this becomes 110. And current next, so current next is equal to new link. So this becomes 90. Okay, so let's try to check if we were able to insert 90 after the current node. So from head, or head points to this node 130. So 130. So this node, it says here next is 120. So this one points to this 120. And this node, it says here that it points to 110. So this node points to 110. And this node now points to 90. So the next node will be 90. And this node points to 100. And this points to null. That means the end of the list. So if you notice that we were able to insert this link in our list. That's why after 110, after this node, it now points to this node, and this node points to the last node. So we have now inserted. Let's try to traverse going back. So this is our last node. Okay, so that's our last node. So our last node, the previous is 90. So this one is pointing to this. And this is points. And this node, the previous is pointing to 110. And then this node is pointing to 120. And this node, the previous one is pointing to 130. That's the reverse, traversing it in the reverse way. And the previous now is pointing to now. That means the end of, or the beginning of the list. So again, we were able to insert this new link in our list using this algorithm.